Hello class, so we'd like to look at the homework from September 12th, and then we'll try to go through them together. The first question, we have to simplify this radical, negative 3 to the 15th power. Now, so you can look at this one in this way. First, even if you to raise this one to the 15th power, you will still have negative sign, so we can say negative 3 to the 15th power. Now, then this means square root of negative 1 followed by 3 to the 15th power. Now this portion becomes I, and while here becomes 3 to the 7th power radical 3 when you simplify 3 to the 15th power. So therefore our final answer is what? 3 to the 7th power I square root of 3. Alright, let's move on to the next question, number 2. Here we have I to the 3 to the 2012th power. Now, here, if you remember, I actually behaves in the cycle of 4. For example, just to remind ourselves, I to the 0 was equal to 1, I to the first was equal to I itself, I square was equal to negative 1, and I to the third was equal to negative I. Now, notice each one of these exponents were the remainder when you divide an exponent by 4. So now, what we'd like to do today right now is that, yes, we do have 3 to the 2012th power, but how are we going to deal with this one? I don't know what the remainder will be when we divide this one by 4, so why don't we try to start with the smaller number, so 3 to the first. When you divide this one by 4, then you will end up getting 3 itself. So we're going to write it as 3 mod 4. When you divide by 4, the remainder is 3. Basically, that's what it means. 3 squared is equal to 9. 9, when you divide by 4, then you get 1 as a remainder. So 1 mod 4. Now, 3 to the third power is equal to 27. When you get 27 divided by 4, you will get 3 as a remainder. So 3 mod 4. Notice that this one repeated itself. Let's see if our next one will repeat. 3 to the fourth power will be equal to 81. So therefore, 81 is equal to 1 mod 4 when you divide by 4. Haha. It seems like 3131 repeats itself, and that's right, that's how it would have been. That means, in this case, what's going to be happening is, every odd number, we will get the 3 remainder. Every even number will get 1 as a remainder when you divide by 4. 2012. That's an even number. So we realize that 3 to the 2012, when it's divided by 4, you'll follow the same pattern as the even numbers, which is 1 mod 4 is what you should be looking for. Since 1 is the remainder when you divide by 4, that will be getting us right over here. So this must be equal to I to the first power, which is equal to I itself. So I is our answer. Number 3. We have to rationalize this one. This one was rather simple because all we have to do is look at the denominator and then find its conjugate. So we have 2 minus 3i. Here 2 minus 3i. Then we'll end up getting on the denominator difference of squares because we are multiplying 2 conjugates. So we end up getting 2 squared minus 3i squared. Now if you have to look at the denominator alone, then this becomes 4 minus this becomes 9i squared, and that's equal to 4 minus I squared. I squared is equal to negative 1, so we end up getting 4 plus 9. Hence our denominator is equal to 13. Now how about the numerator? Since this is a perfect square, what we end up getting is first one square, following the sign, 2 times the first one, which happened to be 2, and then the last one, which is 3i, plus 3i squared. Now, the last one square, so this becomes 4 minus 12i, and then plus 9i squared. But 9i squared is equal to negative 1, so we end up getting 4 minus 12i minus 9. Then our final answer becomes, here we get negative 5 minus 12i. That becomes our answer. Now, number 4, we need to multiply this one. Why don't we try to multiply the first one first? So here it goes. We get 1 minus I squared. Then here, and then 1 minus I, and then 2 plus I. So we can multiply this one first. Then we end up getting first one squared minus 2 times the first one times I, the last one, plus the last one squared. That's basically what we end up getting with the first square. And then we have this one, we're just going to go for the FOIL. 1 times 2 becomes 2. 1 times I becomes plus I. Negative I times 2 becomes negative 2I. Negative I times I becomes negative I squared. Then here it goes. This is 1 minus 2I over here and minus 1. On the other end here we end up having 2, and the minus I squared becomes plus 1, so we end up getting 3, and here minus I. Then our final answer before the final answer becomes, here we get negative 2I because those two cancels out, and 3 minus I. Then our final answer is negative 6I, and then becomes negative, negative becomes positive 2I squared. In other words, negative 6I minus 2. That becomes our answer. Alright, number 5. Here it goes. Let's try to raise this one up to the 4th power. So first let's try to do the square. First, radical 3 over 2 plus I over 2 squared, and then we can simply square that. So first let's try to do the inside. Here then first one squared, which is 3 over 4. Following the sign in the middle, times 2 times the first one times the last one, I over 2. And plus the second one squared, that means I squared over 4, and whole thing squared. That's basically what we end up getting. Then here 2 and 2 cancels out. So term with the I is plus radical 3 I over 2. But here this is negative 1 or positive 3, so we end up getting 2 over 4, whole thing squared. In other words, this becomes 1/2 plus radical 3I over 2 square. So we still have to do the outer part, which is simply square. Then here we go, 1 over 4, first one square plus 2 times first one times the second one, 3I over 2, plus 3 over 4 I squared, 3 over 4 and I squared. That's basically what we have. If you have to simplify this one further, we end up getting, yes, 1 over 4. These two cancels out. We have plus radical 3I over 2, and then here it goes, negative 3 over 4. Then our final answer is negative, and 1 minus 3 becomes 2. 2 over 4 becomes actually 1/2, negative 1/2 plus radical 3I over 2. That becomes our final answer. Alright, great. Have a nice day. I'll see you later. Bye-bye.